Hi, hello. In this week's first lab, we're going to observe a object that is moving at the same speed without changing direction. So in our computational model, we need to firstly see F net force, which is equal to ma, our Newton's second law. And since velocity is constant, we know that our net force is zero because acceleration is zero. Therefore, we can see that our final position vector is equal to initial position plus delta t times constant velocity. Therefore, for our computational model, I simply set our initial velocity, our initial position vector and velocity vector, and I set here our coefficient as 0.01 in the x-axis, and let's run this program. Yeah, so you can see that our object is moving towards positive x-axis, and we have a linear function, which is straight line, which is basically like x is equal to ax. And then I asked my roommate to push a ball on a surface, a flat surface, in the tracker. Let's view this. This one here, yeah. So you can see the ball is moving at a constant speed on the table, and I set each track to see it in a graphic way. If we start to analyze our position, let's right-click this and our data tool, you can see that like we have a linear function here, and the coefficient is like minus 0.7.6 minus 0.7618. This is our velocity, constant velocity, because we are pushing our ball towards the negative x-axis, and this may be the why this constant is negative. So in our computational model, if we edit it, like change this coefficient to this specific value, and then we run this program, you can see that our object is moving towards the negative x-axis, and the linear function is pointing downwards. So therefore, we can conclude that our moving direction either towards the negative x-axis or positive x-axis is depending on the initial pushing force. And the reason why we have a zero net force is because of the frictional force on the surface and the air resistance force. So the ball is moving at a constant velocity, and the computational model is consistent with the real world model, which is a ball pushed by my roommate. You can see here. So I proved the experiment result, and that's it. Thank you.